Hey, welcome back to section 10.7, Pre-Calc Excel students. We are going to continue on with the second part of the lesson. Keep in mind these are the equations or the conversions that we'll use to go from polar to rectangular, right? X equals r cosine theta, y equals r sine theta, and from rectangular to polar. Okay, so let's go ahead and get started. With our first equation, we have y is equal to x squared. So our goal is to change what was rectangular into a polar equation. So if possible, we want to get it into the form r equals. Keep in mind that's not always possible. There are equations that are polar that don't have any r in them at all, which you'll see as we go along. But if we can, we like to get in the form r equals if possible. So let's see, we need to replace y and x. So y we know is r sine theta, and x we know is r cosine theta, and we're squaring that. So that becomes r squared cosine squared theta. Now, ordinarily, if we were solving algebraic equations, we always say don't divide by r, right? Don't divide by a variable. With polar equations, it's okay to do that. So I am going to divide by r, and I'm also going to divide by cosine squared theta. So these reduce out. I have sine theta over cosine squared theta. And on the right, a set of r's reduces out, and the cosine squared thetas reduce out, so I just have r. Now, sine theta over cosine theta, we all know that is tangent theta. And that leaves us with a 1 over cosine theta, which is secant theta. So there's our polar equation. R equals tan theta secant theta. And you could verify this on your calculator. Change your mode to polar mode, same way that you changed it to parametric, same spot. Just go 1 over and highlight polar. And if you enter tan theta, secant theta into your y1, you should see a graph that looks like x squared. Okay, letter B, we have 2xy is equal to 1. So again, our goal is to get rid of the x and the y. So I'm going to replace x with cosine theta and y with, oops, I forgot the r. Hang on a second, back up. R cosine theta. And replace the y with r sine theta. So here I have 2 r's, so that gives me an r squared. And then I'm going to divide by everything else. So I have 2 sine theta cosine theta. So do you recognize this from our identities? 2 sine theta cosine theta is sine 2 theta. Now you'll see when you start comparing your answers, for a lot of these you're probably going to have to flip back, look at the answer, maybe go a little further with it. For the most part, you don't want to leave it in fraction form if possible. So we would use the reciprocal function here and make that cosecant 2 theta. Okay, so that's as far as we can go, and it's okay to leave things. Sometimes it does have to be left in terms of r squared. Okay, that's another possibility. Now we're going to go in the other direction. We're going to start with a polar equation and change it to rectangular, and then describe the graph. So we're going to, these are sort of in backward order, but we're going to find the equation. I mean, if you can, it would be good. I don't know if you recognize this yet or not, but we'll see. Okay, so now we want to get rid of r. So we're going to replace r by using our equation, but the first thing we need to do, we want an r squared, right? So there's a couple options. Sometimes you might want to multiply by r, sometimes you might want to square both sides. In this case, we want to square both sides because we don't want to change the 1. We want to leave that alone. So if I square both sides, I get r squared is equal to 1. Now I can replace r squared with x squared plus y squared. And there's my rectangular equation. It's the circle, right, centered at the origin with a radius of 1. So it would be this circle here. Another way to think about it is that since it's r is equal to 1, it's all of the points that are 1 radii away from the pole. 1 radius away from the pole. Okay. Next, now we see this is a good example of where we don't have an r at all. This is a polar equation. Theta is equal to pi over 4. So perhaps you can think of what this is the graph of. If not, I'm sure you'll recognize it as soon as we start solving. So let's replace theta. Actually, we're not going to replace it. Let's take the tangent of both sides. There's lots of different techniques here. Lots of different things you can try. Okay, if I take the tangent of both sides, now I can do a substitution for tangent of theta. Tangent of theta is y over x. The tangent of pi over 4 is 1. And then cross multiplying gives me the line y equals x. So maybe you recognize that from the polar equation, right? In this case, it's the line where all the points are theta, have a theta value of pi over 4. And they make up that line. The same line, if you put the rectangular grid over top of this polar grid, would be the line y equals x. Okay, r is equal to cosecant theta. So let's see, what can we do with cosecant theta? We could make that r over y. And then if I interchange these two, or you could, as a property of proportions, I can interchange the r and the y. Think of this as over 1. So I get y is equal to r over r, which makes y equal to 1. So this one, it's a little harder to explain in polar form. We all recognize this in rectangular form as the line, the horizontal line, y equal to 1. In polar form, it's the line where all of the r values would be equal to the cosecant of theta. And they form this line on the polar grid. Okay, this last one, this is challenging. I'll give you a hint here. The identity that I would use, because remember there's 3 choices for cosine 2 theta. I would use cosine squared theta minus sine squared theta. This is really a tough one. I wanted to give you a chance to try to work on this one. So go ahead and pause the video, give it a shot, and then come back when you're ready. Okay, let's see how you did. Okay, so here, I got my squares there. I distributed, oh, I didn't distribute the 3. So let's put parentheses there. So I have r is equal to 3 cosine squared theta minus sine squared theta. Then I divided by the 3. And then I multiplied both sides by r squared. Okay, the reason I did that is because I already had the squared, cosine, and sine. So in order to do a substitution, I needed the r squared. So r squared cosine squared theta gives me x squared, and r squared sine squared theta gives me the y squared. So over here, I didn't multiply these together. I wanted to write them out. This would be the square root. Looks like some of my writing disappeared. This was the square root of x squared plus y squared. That comes from just the r. And r squared is x squared plus y squared. So when we multiply these together and add the exponents, think of this as being raised to the half, then this becomes x squared plus y squared to the 3 halves. I multiplied by 3 the same time, so now the 3 is over here. And then I squared both sides. I'm missing a parenthesis there. So squaring both sides takes care of this exponent, makes the exponent a cube. So it just cleans it up a little bit. But this is number 110 in your book. And this is how they leave the answer. So again, it takes a little bit to get used to how far do you go with the problem. You're just going to have to sort of check with the back of the book. But mostly you want to avoid fractions. If you can, you want to get the polar form in r equals if possible. You don't want to leave exponents like 3 halves if you can get away with it. So after you try some, I think you'll start to get used to it, and you'll see, hopefully you'll see the way that you need to leave your final answer. Okay, so that concludes our lesson for 10-7. If you have any questions, remember you can join me any day on Zoom from 11 to 12, and it doesn't have to be on your cycle day. So just look on the website for the ID and the password and join me on Zoom if you have any questions. Have a good day.